this video, we are going to discuss about polar form of complex number. Instead of representing a complex number as x plus iy in rectangular coordinates, the polar form expressed the complex number in terms of its magnitude r and amplitude means the angle theta. On the screen you can see the polar form definition of a complex number, which is r times the quantity cosine theta plus I times sine theta. The polar form of complex number is very useful to simplify complex number operations like multiplication and division, making calculation very straightforward. Using the concept of right angle triangle and trigonometric ratio, it is very straightforward to calculate the value of z, which is x plus iy, in which x is r cos theta and y is r sin theta, provided that the absolute value of the complex number z modulus is equal to r. Among the several benefits, one is the multiplication, which we are going to see. Let z1 r1 cos theta 1 plus I sin theta 1 and z2 r2 cos theta 2 plus I sin theta 2 are two complex number. Then their multiplication is r1 times r2 times cos theta 1 plus theta 2 plus I sin theta 1 plus theta 2. For the straightforward proof, we will multiply algebraically. Once we multiply the term, in place of I square, we will write minus 1. And then we will organize the term without coefficient I and with coefficient I, in which cos theta 1 plus theta 2 represents the first part and sin theta 1 plus theta 2 represents the second part. With this, we conclude that the multiplication of a two complex number is the product of its magnitude and the sum of its amplitude. The essence of polar form of a complex number can be seen in a theorem called argument of the product of two complex numbers z1 z2 is the sum of the argument of z1 and z2. Means when we multiply two complex numbers z1 and z2, we will get r1 times r2 the quantity as a magnitude and theta 1 plus theta 2 the quantity as amplitude. Similarly, the polar form can also be used to find the inverse of a complex number. Means z r cos theta plus I sin theta be a complex number, then its inverse will be 1 by r times cos theta minus I sin theta. For the proof part, let us suppose the inverse of a complex number z, which is z inverse, is capital R times cos phi plus I sin phi. Then by the algebra of complex number, z into z inverse is 1 in the extended form, which is r cos theta plus I sin theta times capital R cos theta plus I sin theta equals to 1 0. By the ordinary multiplication of complex number, we will get that the result is r times r cos theta plus phi plus I sin theta plus phi is equal to 1 0. Equating the real and imaginary parts separately, we will get r times r cos theta plus phi equals to 1 and r times r sin theta plus phi equals to 0, which gives that the capital R equals to 1 by r and phi equals to minus theta. Thus, the complex number z inverse is 1 by r times cos theta minus I sin theta.